Hello and welcome to part 4 of the Orbital Yacht Club presentation. For the past 35 years, I've been sharing a vision of a permanent human settlement in space with anyone who will listen. However, I always preface the vision with the statement, one of these days. A few years ago, I realized we have everything available to actually do it now. Not in a small tin can environment with all the complexities of microgravity, but in a spacious platform with all the utility, security, and luxury we've come to expect in our lives. Be sure to like us on YouTube, post an awesome comment, and share it with your friends and family. Let's make this thing go viral so we can get it the attention it deserves. In part 4 of the presentation, we show we show you additional engineering, the budget to build the Orbital Yacht Club, and some competitive analysis. The, the engineering criteria includes making a commercial space station with private space yacht docking, including Earth, Mars, lunar, and microgravity zones. It has to be spacious and affordable for the purposes of science, manufacturing, and vacations. It should have the ability to be transported to other orbits, including the Moon, Mars, and the asteroid belt. Let's take a look at the logistics of launching the materials into low Earth orbit. Each launch will carry 3 modules and the ancillary equipment needed to operate the station. Launch 1 includes an Earth module, a pair of lunar modules, and an elevator module. As we add additional launches, I noticed after just 10 launches, we have enough of the station to test all of the gravity zones, the elevator, and even the transfer hub. Then we continue to build out the full station with the rest of the 40 launches needed to supply the materials. We will need to rotate crews of astronauts to assemble the station over the course of 5 years. This will also give us the opportunity to have members of the yacht club visit the station as it is being built, so they don't have to wait for 5 years before checking it out. Once the entire station is assembled, we will put it into full operation to inspect everything is working properly before approval of a certificate of occupancy. Each space yacht is individually owned, so they may be purchased from any manufacturer provided it's certified to be compatible with the Orbital Yacht Club. Let's take a look at the docking procedure. Similar to lifts used by private ocean yachts, a lift will be extended from the docking port to capture the orbital yacht. The yacht attempting to dock will travel in a tangential path to protect the station and the other yachts from a collision. Then it will be lifted onto the docking port. The lift will also act as a shock absorber as the yacht goes from 0G to 1G the moment it is captured by the lift. To undock, the lift lowers the yacht to a safe distance and releases it for deorbit back to Earth. If for any reason the lift does not capture the yacht, it travels safely past and can circle back for another attempt or deorbit back to Earth. Either way, the astronauts, the station, and the yachts are safe and unharmed. This is very similar to an aircraft carrier when a jet misses the braking cable while attempting to land. Here's the docking procedure in full motion. Because of the tangential path, 2 yachts may dock at the same time without risk of collision. Once captured, they will be lifted to the docking port to undock. They're lowered at a safe distance and released. Again, if for any reason a yacht is not captured by the lift, they go right by without a collision. In order to highlight the simplicity of the design of the Orbital Yacht Club, I've not been showing the mechanical systems needed to operate the station. Using only existing technologies that are off the shelf, here are the electrical, plumbing, AC, propulsion, and communication system needed for full operation. The dark rectangular circles, the dark rectangles are solar panels that are the same size as what is currently used on the ISS, but there are more of them here. Traveling in a sun-synchronous orbit allows for a maximum power generation and improved solar radiation shielding. The gray circles represent water and air tanks for plumbing and air conditioning to recycle water and air using existing technologies. The small light gray triangles are the same size as the active thermal control panels used on the ISS. To maintain a stable orbit, a second stage rocket can attach to the micro-G hub. This can also be used to maneuver away from potential collisions with orbital debris. The spin rate for the artificial gravity is maintained with Draco engines attached to the Earth modules. The lunar and micro-G hubs are each attached to rails with maglev engines to maintain the proper spin rate in relation to the Earth modules. The communication systems are the same as what's used on the ISS. All of these systems are attached to the Orbital Yacht Club on active anchors to provide an active balancing system that eliminates wobbling as yachts enter and leave the docking ports and people move through the station. 78,000 square feet can be added with an additional ring at 91 meters radius to provide Venus gravity. Several of these modules can be used for science, training, and tourist areas. 3 or 4 layers per floor multiplies each square foot to provide additional acreage for farming food to support 320 people. This would also provide enough space for a cow barn, pigsty, and chicken coop for meat, dairy, and egg production, not to mention tanks for salmon, trout, and shrimp for seafood production. And of course, it's always spinning at 3 rotations per minute. This is the budget estimate for the Orbital Yacht Club. I used NASA budget data and other industry cost data for this budget. 40 launches for equipment and 10 launches for astronauts for a total of 50 launches at $100 million each is $5 billion. Solar arrays, batteries, wire, conduit, and electrical fixtures is between 1 billion and 1.2 billion. Freshwater and wastewater containers, air containers, active thermal control systems, pipes, ducts, fixtures for plumbing and AC is between 800 million to 1 billion. Liquid rockets, maglev train power and rails for propulsion, and communication antennas, cable routers, Wi-Fi for communication systems is far less than $1 billion. Ground crew, astronauts, engineers, manufacturing the modules, support buildings and vehicles, FAA and FCC license, etc. I found it very difficult to come up with $1 billion here. Then I added another $1 billion just to be on the safe side. That adds up to $10 billion. Divided by 40 docking ports comes out to the $250 million per port. And estimating it will take 5 years means each owner will pay $50 million per year per docking port. This is very affordable for any multi-billion-dollar government agency, corporation, partnership, or individual. This is my analysis of the competition. MEV 1 and 2, Mission Extension Vehicle, is built and operated by Space Logistics, a division of Northrop Grumman. They've completed 2 successful missions to repair satellites. They also claim robotic assembly capabilities in orbit. Robotics do not have the flexibility of humans to repair satellites, so the Orbital Yacht Club has a much broader range of capabilities in this market. Axiom is currently contracted with NASA to be the first privately owned and operated module, Hub 1, on the ISS for manufacturing. Because of the complexities of microgravity, Axiom will need to change crews every 6 months. Therefore, by eliminating the need to change crews, the Orbital Yacht Club can produce micro-G manufacturing much more cost effectively. The Lunar Gateway development is managed by NASA, who contracted Maxar Technologies and Northrop Grumman to build it and SpaceX to launch it. It's hard for me to understand how they can propose a lunar gateway without artificial gravity, knowing that people cannot effectively stay longer than 6 months. Although the Orbital Yacht Club probably takes more capital expense up front, the operational expense of changing crews every 6 months, 250,000 miles away, it's got to be far more than any capital expense the Lunar Gateway is saving. This one's interesting. The Voyager station is proposed by the Orbital Assembly Corporation, founded by ex-NASA employees, currently seeking funding through the Gateway Foundation. At 200 meters in diameter, this is the same size as the Orbital Yacht Club, but they're only offering lunar and microgravity. The only reason I can think of is their structural architecture will not support the weight of Earth gravity. As a result, the Orbital Yacht Club is far better just because of our different gravity zones. And by the appearance of the illustrations, their architecture looks much more complicated than the Orbital Yacht Club. So the Orbital Yacht Club is by far the best commercial space station compared to anything currently in use, currently contracted, or currently proposed in the industry. This concludes part 4 of the presentation. If you haven't seen parts 1, 2, or 3, check them out. Be sure to like us on YouTube, post an awesome comment, and share it with your friends and family. Let's make this thing go viral so we can get the attention it deserves. Thanks a lot and have a great day.